Alright, this is your asynchronous session for week 4 recording. We're going to talk about lesson 12, transformations of graphs. The objective is that students will be able to compare and contrast transformations. Students will be able to graph transformations based on mapping statements. So let's first go over some key terms that you'll need to know. So you need to know what a mapping statement is. A mapping statement is a mathematical statement that describes the way a function is transformed. So it will have whatever the function name is, so like f of x. Then it will have an arrow, because that means that this is what this original function, how it's going to change is it's now going to go to, let's say, like f of x plus 3. That's an example of a mapping statement, and we'll talk about exactly what that does to the graph in a little bit. A translation is a rigid transformation that maps each point in a figure the same distance in the same direction. So you probably remembered this from geometry class. An image is a figure after one or more transformations have been applied. So that's our final image that we get after we go through our mapping statement. And the pre-image is a figure before a transformation is applied. So that's our original image that we have when we're first trying to graph the transformation. It's whatever we first get, whatever the graph looks like first is our pre-image. So let's look at rational and radical transformations. So we want to translate the function f of x, which equals 1 over x, by the mapping statement f of x goes to f of x plus 3. So a lot of times the easiest way to do this is to actually just go ahead and graph 1 over x. And then this plus 3 at the end here, since it's on the outside of our parentheses, this plus 3 means that we're going to move every point up 3 units. So the way that graph is going to look is it's going to look like this. So we have our original function is here in black, is our original function. Then all we do is we took each point, so like let's say we're looking here at this point, it was originally at 1, 1. Well, we go up 3, so we went up 1, 2, 3, and now it's at 1, 4. So we just moved every single point on this graph up 3 units. That's what this plus 3 means. It means we're taking our original function and we're just moving the whole function up 3 units. So that whole graph is just going to get shifted up 3 units everywhere. Okay, let's look at another one. Translate the function f of x equals the square root of x by the mapping statement f of x equals f of x minus 2. Now this one's a little bit different. If you notice now, instead of having like on the other one we had the plus 3 outside the parentheses, we now have minus 2 inside of our parentheses. So it's a little bit different this time. Instead of moving up and down, it's going to move it either left or right. So if we look at it, if there's a negative, you would normally think that a negative goes to the right, but it doesn't. The negative does not go to the negative. You would actually think, let me repeat that again. The negative you would think goes to the left because it's a negative, so negative numbers are to the left. But we actually do the opposite of the sign. So since this is a negative 2, that means that we're going to go right 2. If it was a plus 2, we'd go left 2. So as you can see here, if we take a point like 0, 0, we move it right 2 to our new 1. So that's what we do with all of the points, is we moved all of our points here on our graph to the right 2. Okay, let's look at another one. Transform the function f of x equals 1 over x by the mapping statement f of x goes to 3 f of x. So now we have the number out in front. So we have 3 out in front. When the value here out in front is greater than 1, that means that you're doing a dilation. When it's greater than 1, that means that you are stretching your graph. So your graph is becoming bigger. So as you can notice, we just take every point and we multiply the y value by 3. So our graph is becoming bigger. It's going farther away from our axes. If it was less than 1, then it would be getting compressed and becoming closer together, becoming a little smaller. So it becoming close to each other. Okay, let's see another one. Translate the function f of x equals the square root of x by the mapping statement f of x goes to f of 1 half x. So now instead of having a number multiplied out in front, we now have it multiplied on the inside. So if we look at our function, it starts in the same place, but if you look, it's now just closer to the x-axis. When it's less than 1, you're closer to the x-axis. When it's greater than 1, you're farther from the x-axis when it's inside the parentheses here and being multiplied by x. Okay? Now, what about if we add a negative out in front? What does that negative out in front do if we're just doing a negative? Well, all the negative says is that we're reflecting it over the x-axis. So that means we're just flipping it over. So you can see our normal function of x squared here. All we did is we flipped it over, so now instead of it being an upward parabola, it's now a downward looking parabola. So that negative out in front, remember, just makes it reflect over the x-axis. So let's see if you can do this. Go ahead, pause the video, see if you can write the mapping statement for this. How does f of x get to g of x? Alright, now that you've had a chance to do it, let's look at it. Well, if we look at f of x and we look at g of x, it's just a reflection over the y-axis. So when it's a reflection over the y-axis, we're going to have our negative inside of our parentheses there. Remember, when it's over the x-axis, it's out in front. When it's over the y-axis, it's inside of our parentheses. So now go ahead, pause it, and see if you can do this one and figure out what this one is. Alright, now that you've had a chance of doing this one, it's going to be, well, we can notice that it went from being upwards to downwards, so we know it's going to have a negative out in the front because it's now facing down. The other thing is, if I look at my vertex here, it goes up 1, 2, and 3, so that means I'm going to move every point up 3. So this one has two transformations in it. We have it moves it up 3, and we also have that it flips it over the x-axis. So there's two transformations in this one. You can have multiple transformations within the same one. Let's now talk about trigonometric transformations. Translate the function f of x equals cosine x by the mapping statement f of x goes to f of 1/2 x. So remember, we have it inside. So when it's inside, it's going to extend our graph. So when it's a cosine function like this, it extends our graph. So we have our regular function here of the red, and you can see it's much tighter of a curve than our green one is more laid out. It's more wide. So when this number here inside is less than 1, that means our graph is going to be stretched out more horizontally. It's going to be a little bit longer. Whereas when it is a number greater than 1, that means that it would become that these curves here would become closer together. So we wouldn't have this much distance here between one bottom and the next bottom. They'd be a little bit closer depending upon what that number is. So now we have cosine of x, and we want to translate it just with the negative out in front. So remember, the negative out in front, it's the same when you flip it over. So our original function here, we got the green one is our original function. When we flip it over, well, we just change every point. Instead of it being a negative one here, we now have a positive one. So we just flip it over the x-axis. Now, what happens when we have it inside? Well, remember when we had it inside before, we do the opposite of the sign. So you would think that this would go left, but it actually goes right. And it goes right. We're just shifting every point right by pi over 2. So if we look at our graph, if we pick a point, so I'm going to go ahead and I'm going to pick a point here on my axis of the f of x and g of x labels are backwards here on this one. So I'm going to pick a point here. We're going to start on our f of x, which is the red, at here. So I'm going to take this point and I'm going to shift it to the right by pi over 2. Then for this red one, we shift it to the right, pi over 2. So that's all that this graph is doing, is we're shifting it to the right, pi over 2. Alright, now we have minus 2. Remember that when we have a number here on the outside of the parentheses, it either goes up or down. So since we have a minus 2 out here, that means that we are going to go down 2. So we take our cosine, our original one here of red, and we're just shifting it all down 2. So you can just see the whole graph just got moved down 2 units. So see if you can figure out this one. So f of x is the red, g of x is the green. See if you can figure out how to get from the red to the green. You can go ahead, pause it, and then when you figure it out and you have your mapping statement written, come back and see if you got it right. Alright, so now that you've had a chance to try it, let's see what it is. So for this one, it is that we have f of x equals negative x. The negative is on the inside, so what that means is that we're flipping it over the y-axis. Now when you're working with trig functions, you may have also written this as f of x goes to negative f of x. With trig functions, you can sometimes have it to where it's the same thing no matter which way you flip it. So whether you flipped it over the x-axis or the y-axis, you still get the same equation. So those are both possibilities that you could have for this one. So sometimes there may be multiple mapping statements that make sense for a graph. So go ahead, pause the video again and see if you can figure out how you get from the red to the green. Alright, so now that you've had a chance, our mapping statement is that we are moving everything. If I look at this point here at pi over 2, well, the new one on the green graph is it gets moved to the left pi over 2. And if I continue that pattern here with other points, it's always getting moved left pi over 2. So remember, we do the opposite sign inside of our parentheses. So if it's moving left, you normally think minus, but remember it's always opposite. So we have plus and then the pi over 2, because that's how much it is shifting. Let's now move on to logarithmic transformations and see how logarithmic functions. So if we translate the function f of x equals log x by the mapping statement, f of x goes to 3f of x. Remember the number out in front. If it's greater than 1, it's going to stretch it. If it's less than 1, it's going to compress it. So it's going to either become bigger or smaller. So you can clearly see here that our new graph, the purple one, because we multiplied our function by 3, it's now much bigger. It's much wider and farther apart from each other. Okay, so now if we put a 1/3 on the inside, our graph is now going to kind of get a little compressed. It's going to get closer to our x-axis. Remember, if the number inside is less than 1, between 0 and 1, it's going to get closer to our x-axis. If it's greater than 1, then it's going to get farther away from our x-axis. So here is a table that will help you out if you aren't remembering it. So this may be a good table that you write down in your notes so that you have it. It helps you figure out which translation it is based on what the mapping statement is or what you're seeing in the function. It also tells you about how the inverses end up happening. So we have the mapping statements for the regular ones, regular transformations. We also have them for if we have an inverse function, the mapping statements for the inverse function and what it would go to if we're doing the inverse of a function. So if you're going to write that down, go ahead, pause the video and write it down in your notes. Otherwise, the exit ticket, which will be one of your questions, is what is the mapping statement for the graph? So you need to figure out the mapping statement. Remember, to get your points, you need to go back to the asynchronous activities announcement. Click on the button that says click here for the check for understanding. Answer those questions and submit it to get your points for doing the asynchronous session for week number 3.